this video for confidence intervals for difference of proportions. By the end of this video, you should be able to determine whether or not the conditions are met for constructing a confidence interval about the difference of between two proportions, and you should be able to construct and interpret a confidence interval for a difference of two proportions. So our scenario today is talking about prom, and ultimately they want to know what the true difference in proportions between juniors attending prom and seniors attending prom. So let's start by getting our point estimate. So they have random samples of 50 juniors and find that 28 are planning prom. So 28 out of the 50 juniors that they talked to are planning on attending prom, which gives me a p-hat of 0.56. Now they've labeled this p-hat 1, so 1 is for the juniors. Then they have a random sample of 45 seniors and 29 are planning on attending prom. So 29 divided by 45 gives us a p-hat of 0.64. So they want us to construct and interpret a 95% confidence interval for the difference in proportions of juniors and seniors who are planning on attending the prom. So the difference in proportion of juniors and seniors, so they have juniors minus seniors is how this is set up. So 0.56 minus 0.64 is negative 0.08. Okay, so there's a negative difference here, which is fine. That just means the juniors were less. Okay, now let's check our conditions. When you're checking conditions for two different samples, you need to address both of them individually. Okay, so for random, we had random samples of 50 juniors and 45 seniors. So you want to address both of them individually. Same when we get to our 10%. So we had 50 juniors and 45 seniors, which when you think about it means the population of juniors has to be 500 and the population of seniors has to be 450, which is a lot of students. But it does say up here the student council at a large high school. So Etowah would be considered a large high school, and we have more than that many juniors and seniors in our classes. So we're going to say 50 is less than 1/10 of the juniors, and 45 is less than 1/10 of the seniors. So we addressed them all separately. And now our large counts. So for our large counts, when I look at my juniors, both groups, success and failure, junior, not junior, are greater than or equal to 10, or going, not going, sorry. And my seniors, going and not going, are also both greater than or equal to 10. So our sampling distribution would be approximately normal. Okay, remember we checked the 10% because we're sampling without replacement, and we're okay because we took less than 10% of the population, and we want to be sure it's random so we can generalize our confidence interval to the population. Okay, all right, so now let's construct and interpret a 95% confidence interval for the difference of proportions of juniors and seniors who are planning on attending the prom. So in general, what we're doing is we're going to find our point estimate, and you're going to add and subtract the margin of error. Okay. The specific formula, how we're going to find our point estimate, is we're going to take p-hat 1 minus p-hat 2, that's our point estimate, plus or minus, to find our margin of error, we have a 95% confidence level, so the critical value there is 1.96, times the standard error of the statistics. So we've done this before. We have two samples here, a junior sample and a senior sample, so we have to find the standard error of them together. Even though we're subtracting, you always add to find your standard error. Okay, so we would take p-hat 1 times 1 minus p-hat 1 divided by whatever the sample size of the first group is, times p-hat 2 times 1 minus p hat 2 divided by their sample size. Okay, what this looks like when you plug it all in is we had the difference of negative 0.08 plus or minus 1.96 times 0.56 times 0.44 divided by 50 plus 0.64 times 0.36 divided by 45. You have to show this set up. You have to do this. Okay, no naked numbers. And so that gives me an interval when I calculate this all out of negative 0.276 and positive 116. So let's make our conclusion here. We are 95% confident the interval negative 0.276 to 0.116 captures the true difference in proportion of juniors and seniors planning on attending prom. Okay, so this wording of what you're looking for should be in the problem, in the question. So if we go back up to the top, it says find the difference in proportion of juniors and seniors who are planning on attending prom. That's what needs to be when you define your parameter, because we didn't really do the state part in this, but that would be part of your defining your parameter and part of your conclusion. Okay. Now, question 4, does the interval provide convincing evidence that juniors have a lower proportion planning on going to prom? Does it provide convincing evidence? I'm going to tell you it does not, and here is why. No convincing evidence. And the reason is if you look at our interval, 0 is in this interval because we go from negative to positive. So no difference is a potential answer, is a plausible answer even. And for that reason, there is no convincing evidence that there is an actual difference. And it doesn't matter which way we are talking because 0 is a possible difference. So 0 is in the interval. As a plausible value. All right, so if we had done this and we had gotten 2 negative numbers, so if our interval had been a negative number to a negative number, that would have meant there was a higher proportion of seniors going because it was junior minus seniors, so negative numbers meant the seniors were bigger. If we had gotten a positive number and a positive number in our interval, that would have meant there was a higher proportion of juniors attending prom. Because we got, well, it was negative first, then positive, because you write them smallest to biggest. That means we can't tell because we can't tell. There's not enough information here. Can't tell. All right, let's turn this over and do a little bit of a summary. So I have 2 things I want to summarize for you. First is the confidence interval for P1 minus P2. We're not using hats here because we're inferring back to the population, so you want to use the parameter notation. All right, let's take a look at our 4-step process here. So for your state, you're going to define what P1 minus P2 is in context. So that's your true difference in proportion. In context. And you want to state your confidence level. I'm going to just write CL. Confidence level equals what percent. Okay. For your plan portion, So previously we took a single sample, and we got a p-hat, and we did a one sample z interval for proportions. This time it's two different samples. It'd be like juniors and seniors. Those were two different samples. So we say it's a two sample z interval. It is for proportions, but it's the difference in proportions. So we're going to write it like that. Show that it's a difference of proportions. In here, you want to make sure that you hit your random, check your 10%, and your large counts. And you need to do this for each sample. So you got to do it twice because it's a two sample. Then we have our do section. Okay, so remember you want your point estimate plus or minus your margin of error. And what that looks like is your point estimate comes from subtracting your sample statistic plus or minus your z star times your standard error. We're going to run out of room here. P hat 1 times 1 minus P hat 1 divided by their sample size plus P hat 2 times 1 minus P hat 2 divided by their sample size. And then lastly, we're going to conclude. And that's the we are whatever your percentage is confidence statement. Look to your problem to help you with your context there. All right. The other part that I wanted to make sure you walk away with is when questions, follow-up questions, have convincing evidence. So convincing evidence, and it depends on the question, but if your answers are both positive, that means your first proportion was greater. If you have two negatives, if your interval is negative to a negative number, that means the second proportion was greater. If you have a negative interval to a positive, so a negative number to a positive number, that means there is no convincing evidence of a difference. Because 0 is in the interval. All right. So negative to positive is no convincing evidence of a difference because 0 is in the interval of plausible numbers. I'm going to help you get started on your check your understanding. Try to finish this all on your own and go see how you did. Check the key for your answers. So in our scenario, we want to construct and interpret a 95% confidence interval for the difference in the proportion of all working women and men who consider the jobs very or extremely important. So we're going to subtract these. So they don't tell us which way to subtract. Back on the other side, it said do P1 minus P2, and they had defined P1 as the juniors and P2 as the seniors. So you actually get to pick. You just need to tell your reader what you're going to do. So I'm going to write, the women were listed first, so I'm just going to write the proportion of women minus the proportion of men. And I'm going to write down here, just to help with this, women minus men. I've defined it now, so my reader knows what I'm doing. And then this is the true difference in proportion of all working men and women. And so what that is you want to rewrite this portion here. The difference in proportion of all working women and men who consider job security very or extremely important. Okay? Right here. Okay? And your confidence level, that's just 95%. Your procedure, this was 2 different samples, so go back and look under your important ideas. Hopefully this has been helpful to you. Give this a try, check your answers. Let me know if you have any questions. See you in class.